After understanding the concept of elasticity of scale and the concept of elasticity of cost and their relevance with the shape of the cost curves, now we are going to learn about the elasticity of substitution, which is another important type of elasticity which we use in production economics. This is basically a useful tool for investigating the relationship between the prices and the choice of technology. So primarily we can say that when it comes to the choice of technology, that is about the mixture of labor and capital, how much of the labor and how much of the capital will be used. That mixture is related with the prices of the inputs, that is labor and capital. How they are related, let us see with the help of this elasticity of substitution. This is basically based upon the substitution effect, as the name goes, that is substitution, and it can also help us to understand the shape of the isoquant curve. How much will be the substitution? Definitely it gets determined by the shape of the isoquants, because we remember that a shallow isoquant, it is likely to show large substitution effects, just like we have in perfect substitutes, whereas one that is sharply curved, that isoquant is relatively small tendency of substitution. For instance, the fixed proportion isoquants in which the substitution is minimum. Now this idea of elasticity of substitution was forwarded by Hicks in 1932. He gave this parameter. The answer of this calculation will be a parameter, which is elasticity of substitution, and it can help us to judge the shape of the isoquant curve. If we look at its formation, it is actually a ratio, and the ratio is between proportionate change in the factor proportions to proportionate change in the slope of isoquant. So this definition needs a little bit of explanation. Primarily we are talking about factor proportions and then the proportionate change in them. So this is one thing that we need to calculate and put in the numerator, and then we will see the slope of isoquant and then calculate its proportionate change as well and put in the denominator. So it's not just one thing that we put in the numerator and the other in the denominator. It is a mixture of things. Now let us unravel this one by one. Primarily we'll talk about the numerator, which is the proportionate change in the factor proportions. Primarily the factor proportions are simply the ratio of the two factors, for example capital and labor, or any other general term, that is V1 and V2. Then the change in this factor proportion can be calculated simply by taking its differential. So we write D with it. So this is the differential of the factor proportions. The third thing that we want to find out is the proportionate change. It's not just change, it is the proportionate change. And for proportionate change, we calculate the ratio of the change in the factor proportions divided by, that is the ratio with the factor proportions. Just like we calculate any single variable, if let us assume that it is just one variable, this is the same variable. So this is the proportionate change that we have been calculating many times for various situations, for example rate of growth of GDP, etc. The only change here is that we do not have just one variable, we have a ratio of two variables in both of the cases. So if we want to simplify it, just assume that this is one variable, because the ratio of V1 and V2 will also be a variable. So now coming back to the original form of it, so this means that we have found the proportionate change in the factor proportion, which is the numerator in the formula, and in the denominator we have the proportionate change of the slope of isoquant. So the same thing will be done for the proportionate change, but the variable that we are talking about, or the value, is the slope of the isoquant. So at the end I can expect this term, that is the differential divided by the original value but it is the slope of isoquant. So primarily we write the formula of slope of isoquant, that is rate of change of one variable due to the other variable, that is v1 and v2. When we want to calculate the change in it, we introduce the differential, and the differential of this rate of change will be here. This is change and this is slope of isoquant, and proportionate change is this, that is the differential of the slope of isoquant divided by the slope of isoquant. Again, you can consider it one variable just to make things more understandable for yourself. Again, you see it's simply the formula of proportionate change. However, since we are talking about slope of isoquant, it's better to write dv1 over d2 in both of these places, which is actually the slope of isoquant. Now we have found the denominator of this formula as well. So let's put them in this formula, and the formula was simply their ratio. So in the numerator I am putting the first value, which was the proportionate change in the factor proportions, and in the denominator it is the proportionate change in the slope of isoquant. This is the elasticity of substitution as per the formula and the definition that we developed here. So it might look a little intricate, however it is not that much difficult, because it is not a very difficult thing to find out the slope of isoquant. We have been doing this, the MRTS, and we can also calculate the ratio of the two inputs that we are using. So in fact the calculations are not that much tricky, they are just a little extra calculations that we have to do in this case. Furthermore, this formula, it's not necessary that it appears in the same way. It can appear in the form of the prices ratios. For example, if I consider the situation of the cost minimization, which is very common in our production function analysis, the slope of isoquant is equal to the slope of budget line curve. We have done this many times. So this means that this is the slope of isoquant and this is the slope of the budget line. If they are equal, it means that their proportionate changes, they will also be equal. So considering this situation, I can write this value instead of this, and here this is the value that should be replaced, and it will be replaced by this value. So in the denominator I'm going to use not the slope of isoquant term, instead the slope of the budget line term, which is this. So in this new version of the formula, you can see that instead of slope of isoquant term, we are using the ratio of the prices term. Here again P1 is the price of V1 and P2 is the price of V2, factor of production. Now this is the second formula of elasticity of substitution. Again, it is not that difficult because we know about the numerator. We can also find the denominator simply by remembering the values of P1 and P2. And now we have the elasticity of substitution. Its value can be either equal to 1 or less than 1 or greater than 1. This is something which happens with every elasticity, that elasticity can be equal to 1, less than 1 and greater than 1. If it is greater than 1, we know that we call it a unitary elastic situation, and in that if 1% change in the ratio of factor prices happens, that is 1% change in the ratio of the factor prices, if this happens, 1% change will happen in the ratio of the factor proportions. And if the elasticity of substitution, that is sigma, we represent it with sigma. If it is less than 1, for example 0.1, it means that 1% change in the ratio of the factor prices, that is this term, this will lead to 0.1% change in the factor proportions, that is the proportionate change in the factor proportions. And we know that in this case the situation is less elastic. And if it is equal to 2, the elasticity of substitution represented by sigma, a Greek letter, then 1% change in the factor prices, that is this term in the denominator, there will be a 2% change in the ratio of the factor proportions, that is the term in the numerator. So this situation is representing a more elastic phenomenon because the sensitivity of the ratio of the inputs is quite a bit or double as compared to the changes in the ratio of the factor prices. And it is also observable in the real life because when their ratio changes, we also change their combination, because if P2 increases, we will go for V1 because V2 will become expensive and we will shift towards V1. Therefore, there will be a change in the combination of V1 and V2, that is the two inputs. The more expensive one or the relatively expensive one will be used less as compared to the one which is cheaper. That is, this situation can also represent a real life perspective. For instance, if this technology is defined as the combination of inputs, it will be explained with the help of the changes in the relative prices, just like we tried to explain in this segment. Now, in terms of partial derivatives, we can represent the same thing, that is the elasticity of substitution represented by sigma, as this. F1 is the derivative of the production function with respect to the first input, that is V1, multiplied by the derivative of the production function with respect to V2, that is the second input, and then the cross partial derivative of the production function with respect to V1 and V2, there its product with the actual production function. So if we calculate these three terms and then put them in this formula along with this already given value of Q, we can get the elasticity of substitution. So this becomes the third formula for the elasticity of substitution that we can calculate, where we know it has a practical relevance, because if the price of oil it changes, what will be the effect on the labor, that is the employment level. So this is something we confront in our real life. This situation is very much common, that how the employment will be affected due to the rise or fall in the price of the other factor. What sort of sensitivity is there in between these two factors of production? In real life, we can also talk about the banking sector, where the banking sector is now adopting more of the technology. So technology, if it is getting cheaper as compared to the labor or the manual work, how the combination will change from more labor intensive to the capital or technology intensive combinations of inputs. So this can be done with the help of this elasticity, which is the elasticity of substitution, and we learnt three formulas of calculating this certain elasticity, which has practical relevance as well. Thank you.